Accuracy and precision. Accuracy. The accuracy of a measurement refers to how close it is to the accepted value. So let's say you know that something is supposed to measure 3 centimeters and you're asked to measure it, or 3 students are asked to measure it. A student might get 1 centimeter, 2 centimeters, so student A might get 1 centimeter, student B might get 2 centimeters, and student C might get 3 centimeters. The person who is most accurate is student C, because we know that the thing was supposed to measure, whatever it was that we measured, was supposed to be 3 centimeters. So that person is close to the accepted value, so they're very accurate. B is more accurate than A, but A is the least accurate out of all of them because it only got 1 centimeter. That student only got 1 centimeter. So that is accuracy. The difference between accuracy and precision, though, is precision refers to the reproducibility of a set of values. So can you reproduce the same results? So if that person kept measuring that same thing and does he keep getting 3? Or does he get 2.7? Then he gets 3 sometimes, then or he or she gets 4, or gets 3.3, and then gets 3. Are they precise? Do they get the same measurements? Measurements that are precise are not necessarily accurate. So this person, let's say student A is doing an experiment, is supposed to measure how many grams something is, and you know he's supposed to have 25 grams, but every time 22 grams, 22 grams, 22 grams. So this person is very, very precise. They're getting the same, they're reproducing the same set of values, but they're not very accurate because you know that it's supposed to be 25 grams. This could be a problem with the human error, what we call human error, meaning that something went wrong with the scale or the balance, so that person kept pushing down on it, or actually keeping it lifted up a bit so that it didn't measure the full 25 grams. Or it could be an equipment error, so the scale is off by 3 grams. So they're actually getting 25 grams, but the scale is off by 3 grams, so they are not getting the right measurements. So it might be an equipment failure. And so knowing about accuracy and precision helps you be a better scientist and understand what's going on in a lab setting, because you can understand where you're supposed to be, what's the accepted value, what other scientists have gotten, and understand if you're being precise and accurate or being one or the other. So another way to look at this is through darts. So here we have 3 pictures. So if I'm shooting an arrow at this dart or target, and we see that first this person is very precise. So he or she is getting all the arrows in this really tight spot. But we know that the objective is to get the arrow in the middle. We know that the arrow should be in the middle, and it's not in the middle. So we see that they are not accurate, but they're very precise. So they can shoot at this part of, they can get that part of the target, but very precisely, but they're not accurate. They're not getting the center. This person, though, is precise and accurate because they're getting the center, and all the arrows are hitting in the same spot. This person is neither precise nor accurate. So this person is not hitting the center, but also hitting all over the place on this board. So they're hitting here, they're hitting over here, they're hitting over here, and not making a dent in the center. So when you think of accuracy and precision, think about the different ways you can be precise but not accurate. So you can get precise readings but cannot be accurate, but you might also get precise and accurate readings, meaning you're going to get things that are right on target and you keep getting them all the time. Remember, precision has to do with reproducibility. So you have to see multiple measurements to make sure that something is precise. Accuracy, you can see one measurement and decide whether it's accurate or not. So reproducibility has to do with sets of data. This can do with one data point.